Hi guys, this is Kunal from Kit Kaksha. So in the previous video we discussed what is socket programming, what do you mean by sockets, what is a client server model. Now going forward, we have this TCP IP model on the base of which we would be writing the socket programming. So in order to do that, we must understand this model and what is it all about. So before TCP, there existed a model called the OSI model, which stands for Open System Interconnections. Now this model has 7-layer architecture with each layer having specific functionality to perform. The OSI model defines a hierarchical architecture that logically partitions the functions required to support system-to-system communications. Now the TCP model on the other hand was designed and developed by Department of Defense in 1960s and is based on standard protocols. The TCP/IP model is a concise version and much more simpler version of the OSI model. It contains 4 layers, unlike 7 layers in the OSI model. So much more difference does exist between TCP and OSI. Like the TCP is much more reliable as compared to your OSI model. The TCP does not have very strict boundaries, unlike the OSI, which has strict boundaries. Protocols cannot be replaced easily in TCP/IP model, while in OSI model, protocols are better covered and is easy to replace with the change in technology. Now, as discussed, the TCP/IP model has 4 layers, that is your application layer, transport layer, network layer, and link layer. So out of these 4 layers, on these 3 layers are not accessible to us as a user. They can be accessed only by your OS or kernel space. So as a user, we can access only your application layer. These 3 layers cannot be accessed to us directly, but we can access them with the help of a socket. So socket, as discussed in the previous video, is a interface between your application layer and the transport layer. So what happens exactly is the application layer writes on socket, then transport layer reads it, then it sends to your network, then your network sends it to link, and then it is sent to your physical layer, that is your modern sockets, switches, etc. So this is your 4 layers in the TCP/IP model. Now we have the TCP server client interaction. So the socket, so these are all APIs, right? The starting with your socket API, it creates an endpoint for the communications and returns a socket descriptor that represents the endpoint. So when an application has a socket descriptor, it can bind a unique name to that socket. The servers must bind a name to be accessible from the network. Then from bind it goes to listen. From listen API it goes to your accept API. Then it reads, writes the data. Then after the process is over, it closes. So the listen API indicates a willingness to accept client connection request. When a listen API is issued for a socket, that socket cannot actively initiate connection request. Coming to client, the client also has a socket API. The bind function in the client section is not compulsory. It may be there, but it's not compulsory. The listen function is missing. The listen API is not there in the client section in the TCP server client interaction model. Now, using the client application uses the connect API on a stream socket to establish a connection to the server. The server application uses the accept API to accept a client connection request. Clients and servers have many data transfer APIs from which to choose, such as your read, write, receive from functions and others. So when a server or client wants to stop operations, it issues a close function to release any system resources acquired by the socket. So the close function marks the end of our process. So going forwards, we have ports and services. So when a client process wants to connect to a server, The client must have a way of identifying the server that it wants to connect. If the client knows the internet address of the host on which the server resides, it can contact that host. So for our purpose, a port will be defined as an integer between 1024 and 65,535. So it would be between 1024 to 65,535, because uh, any port number which is less than 1024 are considered well known. So you cannot assign a port number which is less than 1024 to your server. So a good practice is assign any port number which is greater than 5000. But also one must also keep in mind that there are certain organizations who have written servers having port numbers more than 5000. Like the Yahoo Messenger runs on 5050. So you have to be very sure that that the port number you are using for your server is not used by any well-known organization. Now, here is a small list of services and associated ports. You can find the most updated list of internet ports and associated service at INA TCP IP port assignment. There is this HTTP server which has a port number of 80, that is the World Wide Web. Now, the manner in which computer architectures represent values larger than 1 byte varies. The two common ways to represent values which are larger than 1 byte is your Little Endian and Big Endian. So in Little Endian, low order byte is stored on the starting address and the high order byte is stored on the next address. In opposite of which is your Big Endian, where the high order byte is stored on the starting address and low order byte is stored on the next address. Now, to allow machines with different byte order conventions communicate with each other, the Internet protocols specify a canonical byte order convention for data transmitted over the network. This is known as your network byte order. So, in other words, network byte order refers to how bytes are arranged when sending data over a network. In TCP model, this is known as your Big Endian. Similarly, there exists a term called the host byte order, which refers to how bytes are arranged as compared to computer architecture of host computing platform. This is known as your Little Endian. Now, there are certain rules and conventions, like all network data is sent in Big Endian format, and we convert all data into network byte order before transmission. So these are two rules you have to keep in mind. So there are certain utility functions like H2ONS, H2ONL, which stands for host to network short and host to network long, and this function is used to convert your host byte order to network byte order. In opposite to these two functions is your N2HL, N2HS, which stands for network to host long and network to host long. So using these functions, we would be converting the type of network according to our requirements.